Hello YouTube, next installment on the Jet Go Kart project. I've decided to completely redo my fuel system. I've had too many problems and spent too much money on small tanks for the starting gas, so I've decided, after much debate and trickery, to modify my main fuel tank and put dual valves on it. And here it is. I don't know if you can tell that much about it. Nothing's tightened up yet. I just got it mocked up. What I've got is this bottom valve is going to be the gas supply, and this is the gas solenoid, which has the 3/8 orifice in it. This top solenoid has the 1/4 inch orifice where the liquid fuel, and this is going to be the valve with the dip tube in the bottom. Now let me go ahead and disassemble this. Okay, this one's already set up and ready to accept. These fittings are sealed with Loctite 542. It's kind of like a Loctite thread locker, except it is for gas and hydraulic fittings, and it works dang well. It works so well, I've got one tank out there that I haven't been able to get the valve out of, so you might want to use it sparingly. I can use this valve for the gas supply, but this only has a 1/4 inch orifice in it. The other one has a 3/8 inch orifice, which would make more sense since it worked on the small tank, although the tank could not supply the pressure. So I'm either going to take that valve, if I can get it off that tank without damaging it, I will use that valve, or if not, I may use this valve. Now this one had a dip tube on it. This is the one that was originally in the top of my tank, and here is the dip tube assembly that fit to the bottom of the tank. The only problem with this one is it has a flow limiting check valve in it. It gets over I think it's 1.5 gallons per minute while it shuts the flow off. Of course, this is a rather large tube, and I could see where, yep, that would empty the tank quite quickly. Well, what I'm going to do, and let me go ahead and disassemble this. Now these came out of standard 20-pound propane tanks, and you can see they have the Spitzer valve, which ties into a little port here that a small 1/8 inch diameter copper tube that runs down to the 80% full mark in the tank, so that when the liquid gets up to the bottom of this small piece of tubing, it starts spitting liquid out the discharge port of the valve right there, and that lets you know that the tank is full if you don't have an OPV float on it, and this one no longer does. This also has a 1/8 inch pipe thread in the center of it, which makes it handy, and this hole here goes to the relief valve, so that high gas pressure, anything above 375 pounds, will cause that to the pressure in the tank. Now that's one valve, and here is the other one. The same type valve, just made by different manufacturers. This one's threaded in the center. This one has better quality threads than the other one, and oddly enough they use a 632 screw thread for the copper tube to go in, and I don't have a 632 die. I've got a 632 tap, and I've checked and it fits in there and the threads mesh perfectly. So I've got to run down tomorrow down to Harbor Freight and see if I can pick me up an El Cheapo 632 die so that I can thread this piece of tubing and Loctite it in place and make sure it's cut to the proper length, because I've got to add for the length of this tube to get it down to about the 80% mark, which is, I'm going to say, roughly along in there somewhere. And you can see here where the kind of lines up with the T. Now I'm going to get my tape measure out and make sure of those specs, double check them, but I've got to first determine how far that this T will thread in to that opening on the tank. Now this is a forged high pressure brass T. I paid a premium for this because it was forged and precision machined, and even the threads were precision machined on it, so that I wouldn't have to worry about that. But anyway, that's a standard 3/4 national pipe thread, and once I get that set into place, I'll probably I'll position it when I get the other valves, and I'll have the dip tube in one valve. I'm going to use, instead of that large brass half-inch stuff, I'm just going to use regular 1/4-inch stainless steel, same thing I'm feeding the engine with. And I'm gonna, that, you can see right there, it just lines up with the top of that. You can see inside that there's plenty of room in there for gas to get around that, and there's plenty of room for the 80% sensing tube. So gas will come out the side here, liquid will come out the top here. Got a regular 1/8 inch swedge lock fitting that'll go on that stainless steel tube, which will lock down rather nicely. See, I've got one here is all put together. These are quite solid. Once you get them nailed down, they are nailed down, and I may go ahead and put some red Loctite 542 on that just to make sure that it doesn't decide to move and doesn't have any choice. So that's the setup, and that's what I'm going to end up with as far as a supply line. Let's see, what can I get that in there with that tube in there. Oh yeah, it'll go in enough. See, you can see the tube rattling around in there. It's sticking up through the center of that valve without the fitting on it. And have the other, well, this is a little more difficult one-handed, but anyway, you get the idea. There we go. So I've got plenty of room to tighten that up to where it needs to be, get the position laid in the direction. I can adjust where I want this to go as far as getting the solenoids lined up and making it easy to refill. I'll be able to refill it through either port. Of course, it'll probably be faster through the going through the gas inlet, and I'll still have the 80% pressure sense on the top valve. The bottom 80% I'll Loctite it down so that it's not won't cause a leak or anything. But anyway, and to hold the tank on, since doing that is going to make this tank non-DOT compliant, there's nobody that will fill it up for me. So I'm purchasing the 100-pound residential propane tank, and I'm gonna, this is the valve, and that's the dip tube, those two pieces there. I bought that for a 100-pound tank, and I cut the dip tube down to fit the 30-pound tank, but I can reassemble that and put that back together and silver solder it back together, and it'll be the right length for a 100-pound tank, and I can just change that valve out and not have to spend $100 for a new valve with a dip tube on it. So that being the case, I will no longer be using the ratchet strap to hold the tank in place. I'm going to permanently mount the tank, and for that I have dug into my past here and found me a brand new unused box of wrap lock, 1/2-inch stainless steel banding material for whatever purpose you want to use it for. We used a lot of this in my electronics days. It's real easy to install and very solid. Comes with its own little install wrenches and never been opened. And this thing is probably 1960s, 1970s vintage, but as new as the day it was put in the box, and it's cheaper than buying a minimum quantity of the material that has replaced it, largely the Bandit. This is 304 stainless steel. I don't know if you can get if I can get that to focus in just right or not. Yeah, 1/2-inch wide, 304 stainless. So and take these wire strips off here and just put me 3 bands around that and go around the 2-inch by 2 aluminum frame member on the back of the Go Kart there, and that will take care of securing that tank good and solid. So anyway, that's where we stand. I'm hoping to get this thing put all together tomorrow. I've got my next door neighbor is going to let me use his shop, and he's got a big vise and a hydraulic press and some bigger tools than I've got, and we're going to get that high flow valve I've got in that small tank that I did the demonstration run in the last video, and I'm going to use it as the gas supply right here on the lower valve, because it has a larger orifice in it than this valve. And then I'll use this valve for the liquid feed, and it'll just run down to the bottom of the tank with the 1/4-inch line, which I have no doubt will provide enough liquid to supply the engine, and if it doesn't, then hey, I'll just use the tank until it's empty, and I'll take it apart and I'll replace this 1/4-inch tube with a 3/8 tube using a 3/8 by 1/8 by 3/8 adapter fitting. Or I could just do what was originally in there. There was actually a piece of 1/8 inch stainless steel nipple, and that was screwed into the bottom of the valve, and then the dip tube check valve, flow check, was screwed onto that 1/8 inch tubing. So I could do it that way if I want to. I don't really see having an issue with that. As long as the thing idles good, then I can check and see what the thrust is, and if I need more gas, I can go to a bigger valve. But as long as I get 50 pounds of thrust or better out of it, then that'll be fine. And if it only gets 25 or 30 pounds of thrust, then I guess this 1/4-inch tube won't be big enough. But since that's what I'm feeding the engine, is 2 1/4-inch tubes fed from a single 1/4-inch tube over to the solenoid valve, then I don't figure this being in the dip tube is going to make enough difference to matter. So anyway, kind of a long-winded hodgepodge video. Oh, I've got new ignition system here. I might as well show you this. Been using a spark plug igniter, or a spark igniter from a gas grill, kind that's got the little 1.5-volt battery in it. But I found a company on eBay that makes ignition parts for old hit and miss engines and Model Ts and so on like that, called Flywheel Supply. And this is a coil that they make. It'll work either 6 or 12 volts, and it's in a real nice oak box, really fancy looking, and just happens to be wide enough to fit perfectly on that 2x2 tubing. And instead of using a regular spark plug, I took a long reach spark plug and cut half the thread off of it. Now you have to use a high temperature range spark plug so that you have a long insulator, and I cut half the thread off, which fits flush with the threaded insert that Bob used, so that'll have the insulator sticking directly into the combustion chamber. Now if you'll bear with me just a minute, I will hook this concoction up and show you what it's capable of. First off, get my 12-volt battery here, and alligator clips. Now comes the fun part, and that's this driver circuit that I built. It's a 555 timer driving a solid state optically isolated relay, because 555 is only good for a couple hundred mils drive, and the high impedance mechanical relay that came on this board. This is a Velman project board. Let's see, I can't get it to, is it going to focus or not? No, well, anyway, it's a Velman pulse width modulator, circuit. Blew the first IC chip, went in, changed the capacitor, lowered the capacitance so it raised the pulse rate. Now I'm going to set that right there while I hook this up. You guys are just going to have to bear with me. I know I'm not the greatest. Let's see, that is the relay, that is the positive, so that goes there. And that's the ground, or negative. And this is the negative. I'm going to really have to watch this video, I guess, before I post it. This may be the awfulest conglomeration you've ever seen. But you've got to see this. Okay. Let's take this back in hand here. And just for safety's sake, all right, now watch the little spark plug. Now you think that won't ignite some propane or diesel fuel or whatever? Oh, I love it. That is so much more powerful than that little igniter that came off of a barbecue grill. And this runs on the common battery that powers everything else. So I'll just get me a small plastic box to put this in. There's the part number on that relay. It's a Kyoto KF 0604D, and it's good for 3 to 60 volts DC at 4 amps on the output. Takes anywhere from 3 to 32 volts DC on the input at just a few milliamps, so the 555 can drive it direct without blowing its top. And that is a very respectable spark. Believe me, I got into it the other day. And it showed me just how respectable that it needed to be. So, anyway, that's it for now. Sorry about the jumpiness of the video. It's kind of a last minute idea. I was going to wait until I had everything done on the valve, but had some people want to know exactly how I was planning to do this and what the thought process was, and there's my thought process. I just pile everything on the floor in front of me and I start putting stuff together and seeing which way works and which way doesn't work. And before, I wasn't even going to go with a second propane valve because I didn't think I had the clearance, so I went and bought this cheap Chinese 3/8 ball valve, and fitting to go from 3/4 down to 3/8, and was going to screw this in, and this was going to control the gas flow on off and have full flow. And but I like the idea better of using the regular propane valves than using this, because it takes a little more effort to get them open, and they're made for the service. Of course, this is all stainless with Teflon, and shouldn't be any reason why it wooden seal, but I couldn't find one of these made in the USA at the time I ordered them. And I have had too much bad luck with Chinese made junk. And I just don't trust that it won't be a problem. This may be the best valve ever to come out of China. Who knows? It's supposed to be the stem goes in from the inside of the valve, so, and has two O-rings around it, so it's blowout proof. The way they do that, I don't know if you can see it, there is a insert in there with a hex key in it, hex key center, and they actually put the valve together from the inside. They snake the stem in, put it in place, and then put the first seal in, then drop the ball in and get it lined up with the slot on the stem, then put the second seal in, and then put the gland nut, tighten it down, and then put an insert, I guess press it in, and then machine it flush, because I can't see any way of getting it apart. And it's flush in there, and like I said, it may be a good valve. They say it's rated for 1,000 pounds. So, and it's supposed to be 304 stainless. Of course, I've seen some valves. I've heard some stories from some people that have bought these valves, and they have been varied, so you may get a good one and you may not. Well, enough for going on. This 27 minutes, longest video I've done, I guess, since the engine run. So, thank you for putting up with it. If you watched all of it, have mercy on you. And until next time, thanks for watching.